Good evening, ma'am. I'm Revati K from CSE department. Hi everyone. In this video, we will explore a very smart pathfinding technique called A-star search algorithm. So, usually it is used in maps, robots, games, or anywhere. We want to go from one place to another in the best possible way. So, let's go through it by step. First, let's define a simple graph. Here, the nodes are A, B, C, D, E, F, G, like goal. So imagine we have a small map with seven places. So the weightage edge like cost between the nodes. So we can travel between these places, but each road has a cost. For example, going from A to B cost 1 and A to C it cost 4 and so on. So here's a quick look at all the roads and their costs. So the step two is heuristic value, estimated cost from node to goal G. So now to make smarter decisions like A star uses something called a heuristic. This is just a guess of how far each point is from the goal. So for example, A is guessed to be 7 units away from G. Like A is away from 7 units to G and B is 6 and F is 2. G is 0 because it is goal. So these guesses help the algorithm choose better directions. So it's a pictorial representation of custom graph construction with heuristic and weighted edges. So through this diagram, we can understand easily. The step three is how to make decisions like in the search algorithm implementation. So for the formula f of n is equal to g of n plus h of n. So g of n is how far we have already traveled. That is, it describes a real cost, and h of n is how far we think is left to go guess. So it adds them together. It gives like f of n is equal to g of n plus h of n. Then it picks the place with the smallest f of n. So this helps like A star balance between real cost and future yes. So it moves fast and smart. And the step four is the code. Like in this code, we use a priority queue to pick the best path. So we start from the A star and keep moving forward based on the lowest cost. So we stop when we reach a G. So the G has the null value. The algorithm builds the path and show the total cost at the end. So the Python code the step 5 is the final result. So this is the Python code. Def A star start goal PQ is equal to priority queue. We are defining the variable and the condition, and in the it undergoes through the while loop. So while not PQ is dot empty, and it's describing FG node comma path is equal to PQ dot node. And the if it come under if condition, if node in visited, it will continue and it will add visitor dot add node, and it also add the condition if node is equal to goal. If the condition is satisfied, it will print path whether it belongs to path and the total cost. And then it comes to for loop for neighbor comma cost in graph node. If neighbor is not visited, it will add new of g is equal to g plus cost, and then it will undergo through pq dot put new underscore f new underscore g neighbor path plus neighbor. So the step 5 it will give the final result. And the principles behind a search algorithm is Dijkstra's algorithm, which guarantees shortest path using G of n, and greedy best first search uses H of n to guide the direction. So we already studied H of n is how far we think is to left to guess, right? So the key principle is uses a priority queue like to explore the most promising path first, and it also guarantees the optimal path if the heuristic is if it satisfies the both condition admissible and consistent. Never overestimates the cost to reach the goal if it is consistent or monotonic. For every edge that n which tends to n dash, it satisfies the condition h of n less than is equal to cost n comma n dash plus h of n dash. And the steps it's is its practical application and its significance. So A star is usually used in many real world places like in Google Maps, robots, games, and network systems. So usually in Google Maps, it is used to find the best routes, and the robots to move around safely, and in games to move characters smoothly, and network system to send data efficiently. So it's fast, smart, and always find the best way if we give it good information. So the last conclusion of my video presentation is that yes, A star uses the real cost plus smart guessing. It's like a GPS for computers, and